To sum up this particular chapter, which is quite an important chapter, we started off with what is a trigonometric function, correct? And we discussed with different types of trigonometric functions. Once we discussed about the trigonometric functions, then we discussed about the identities, the three trigonometric identities. Sine square plus cos square is 1 plus tan square is secant square, and 1 plus cot square is cosecant square. We discussed about these three trigonometric identities. Then after that, we discussed about what are the signs of the trigonometric functions in different quadrants. The ASTC rule. A is for the first quadrant where all the trigonometric functions are positive. Second is S, sine and cosecant. Third quadrant is tan and cot. Then the fourth quadrant is cos and secant. So here we are looking at the signs of trigonometric function. Then further, we moved on to the allied angles. How the trigonometric functions are related to one another as they move from quadrant to quadrant. That is, here we are talking about pi by 2 plus or minus theta, or pi plus or minus theta, 3 pi by 2 plus or minus theta, and 2 pi plus or minus theta. Depending on the quadrant and depending on the sign of trigonometric function, how they are placed and how they are related to one another in different quadrants. This is basically the concept of allied angles, which is quite an important part, right? Then as we move on further, we discussed about the graphs of trigonometric function. Now each trigonometric function has a particular graph, like you guys know what is sine, curve, cos, tan, everything. Now here, sine and cos, these are the only two graphs which are continuous, and also they have a particular range of values, right? So sine and cos, they have the maximum value of 1 and the least value is -1. The rest all the functions are open curves, they are not closed. Like tan goes from minus infinity to plus infinity. Same thing for cot and cosecant and secant. They do not have any values from -1 to 1. Their values are more than 1. So from 1 to plus infinity or from -1 to minus infinity. Correct? So these are the graphs of trigonometric functions, and we have discussed about the graph of trigonometric functions. Now once the graph is done, then we moved on to a very important part of the chapter, that is compound angles. Now in compound angles, we are looking at the summation of angles like cos of x plus y, and we derived the formula for cos of x plus y, which gives us cos x cos y minus sin x sin y. The same way we did for cos of x minus y, sin of x plus y, and sin of x minus y, right? So these are the four compound angles for trigonometric functions. And once we have the compound angles, we make use of this compound angles and we can calculate the next type, that is multiple and submultiple angles. So when we say multiple, we are talking about sine 2x or sine 2 theta or cos 2 theta. Likewise, we also go for sine 3 theta, or you can say cos of 3 theta, like this. Now remember, whenever we talk about sine 2 theta, there are two formulas: 2 sine theta cos theta as well as 2 tan theta by 1 plus tan square theta. Likewise, cos has four formulas: cos 2 theta, cos square theta minus sine square theta is 1, or 2 cos square theta minus 1, or 1 minus 2 sin square theta, or 1 minus tan square theta by 1 plus tan square theta. Whereas for tan 2 theta, there is only 1, 2 tan theta by 1 minus tan square theta. Now the next multiple is for 3x, 3x or 3 theta you can call, sin 3 theta, cos 3 theta and tan 3 theta, correct? Now these are multiple angles. Now we have submultiple angles. Suppose if you have sin theta, you can write as 2 sin theta by 2 cos theta by 2, or the same thing can also be written in terms of 3 theta, correct? So sine theta can be written as 3 sine theta by 3 minus 4 sine cube theta by 3. Now, this is what the submultiple angles are supposed to be. Now, after submultiple angles, we discussed about another major part, that is the transformation formula. Now, here we convert the product into sum or difference, or the sum or difference into product, correct? Now, if you have the formula such as sine C plus sine D, then we convert this as 2 sine C plus D by 2 cos C minus D by 2. Likewise, we have for sine C minus sine D, cos C plus cos D, and cos C minus cos D. 4 of them. This is from sum or difference into product. Now, the vice versa is also true. Suppose if you have a formula such as 2 cos x into cos y, then we can write this as cos of x plus y plus cos of x minus y. So we are converting the product into sum, or difference is also fine. Alright. Now these are transformation formula. So till now we have come across a lot of formulas in trigonometry, like a lot of formulas, starting from signs of trigonometric function to allied angles, then moving on to compound angles. With the help of compound angles, we discussed and we derived for multiple and submultiple, and at the end we discussed about the transformation formula for trigonometric functions. Now till here whatever we have done is all about the formulas. The next part is using the formula, how we apply this in an equation. That means we are talking about the trigonometric equations. Here, depending on the value of the trigonometric function, we have the principal value. Now, principal value is always from 0 to 2 pi. That's all. So, where it is plus, where it is minus, depending on that, you are going to do it. Fine. The next type is finding the general solution. Now, general solution is mostly for 3 trigonometric functions, correct? Sine, cos, and tan. Now, when you do it for sine x, then the general solution will be x is equal to n pi plus minus 1 power n into y. Alright, for cos x, suppose if cos x is equal to cos y, then x is equal to 2n pi plus or minus y. Then for tan function, x is equal to n pi plus y. Now in all the cases, n value is it's an integer, or n belongs to the set of integers. Now these are the things what we have discussed. Now this entire chapter is extremely important, and as you can understand that it's quite a big chapter, so it has a lot of weightage. Fair enough? So whatever we have discussed in this entire chapter is summarized in this particular video. Fine. So this is the chapter trigonometry.